Today we're going to go over the foundational operations needed for doing math in Rust. We're going to start by printing out addition, subtraction, multiplication, division, and modulo. Modulo is an operation that gives us the remainder from a division. So let's compile and see. 2 plus 5 equals 7, 2 minus 5 equals minus 3, 2 times 5 equals 10, and 2 divided by 5 equals 0. So because we are dividing integers, anything after the decimal place is dropped. But as we see in 2 modulo 5 equals 2, here we keep the remainder from the division. In other words, 2 divided by 5 leaves over 2. So that's what the modulo operation gives us. So now let's look at bitwise operators. To start, we have AND, OR, XOR, and NOT. So in a U8, we have 8 bits of information. So here's how we count in binary. Every time we hop over in one place, the value doubles. So here's 1, here's 2. Looking at 3, we see that it's 1 plus 2. Hopping over one place again, we get 4. And when we add 1 to it, we get 5. So let's put the values 5 and 3 into two variables. Bitwise operators affect each bit in a variable individually. With the AND operation, the resulting bit is only 1 when both of the inputs are also 1. So here, 1 and 1 are both 1, so the result is 1. Whereas for the rest of them, since at least one of the bits are 0, we get a 0 as a result. With the OR operation, the resulting bit is 1 when either of the input bits are 1. So you see here that in any case that we have a 1, we get a 1 as a result. With the XOR operation, the resulting bit is 1 when only one of the two input bits are 1. So XOR gets its name from the term exclusive OR. Lastly, we have NOT, which flips the bit in each variable. 0 becomes 1, 1 becomes 0, and that is continued for all of the bits in the variable. So we can run and compile and see our results here. A and B gives us 1, A or B equals 7, A XOR B equals 6. And using our calculator, we can confirm this. You can see here, NOT A gives us 250, and NOT B gives us 252. That's way bigger than what we have here. One thing you should be careful with bitwise operations is that it will continue to do them for every bit in the variable. So since we have 8 bits here, every single one of those bits got flipped. Now there's one more topic to cover, and that is bit shifts. These shift every bit in the variable leftwards or rightwards. So let's look at that. We'll start with the mutable variable num. To start, it will equal 1. Now don't worry about for loops yet, we'll cover those soon. Just know that we are repeating the instructions in these braces 10 times. So here we'll see that our num variable is getting doubled every iteration until it starts saying 0. So let's draw this out. We know that originally we started with all zeros followed by a 1. We're moving this 1 over to the right each time. Eventually, the 1 moves off and leaves us with nothing here. This is effectively a very efficient multiplication by 2. We can go the other way to divide. So let's start with 128 and shift left. Here we can see it halves with each iteration until the 1 moves off. When we shift all zeros, we still end up with all zeros. This is all for the operations lesson. Thanks for watching. I'll see you next time.